Okay, so got a little bored today. I'm going to do a little video on 3 of my pet peeves about science videos and how they represent a couple of some things in science videos. First one is going to be a proton because I was just looking at this video. Okay, so almost always when you look at a proton up, it's going to be like this. Seriously. Like this is the way it's represented when talking about a proton. Now, when your average person looks at this, what do they see? It's like, I don't know, some U's and a D in a circle. What does this mean? What does this mean? What information is this conveying? Okay, so what it's conveying is that there's an up quark. So you'd have to know what an up quark was for this to make any sense at all. And it has 3 of them, and it always has these weird, like the bonding is this like this weird thing like this, and they're springing around. Okay, and can I just say, it's like, look at nature for a second. 3 things like that, totally unstable. I mean, unless you're intending on demonstrating how completely unstable this is. Okay, this whole setup, it's asymmetrical to begin with the ups and downs, and then the way that they show these things is like these weird, like springy bond things like this. Okay, on a plane, what? How does that make sense in our 3-dimensional world? Okay, like really, this is not conveying very good information about what a proton is, or how a proton is almost certainly constructed. Okay, so you want to show that it's an up and a down. Why exactly? We're talking about a proton. Even if you're looking at the structure, maybe you'd go like this. You could go like this, like U1, because there's 8. There we go. 1, 2, 3, 4 axes of charge from the ups, but then maybe there. This tells you that there's ups. This tells you that there's downs. It tells you that the exposed charges that remain are ups, which means that they've got a positive charge. It shows that there's an up and a down interlocked in the middle because there was an extra charge left over, which have now canceled and become that photon that's mass. Okay, something not that weird 3 balls together that don't really make any sense or inform anybody about anything about it. First pet peeve. Second pet peeve, photons. Okay, inevitably, photons are represented by representing one of the fields, and I think I can do this. Representing the contrasting field, and this is like the, oh yeah, that should have matched up better. Anyways, boom, right? This is like the electric field, this is the magnetic field, this is the photon. Okay, first major peeve with this is a photon. A photon is a singular thing. It is not a series of waveforms, a singular thing. So at the very most, you get 1 sine wave. There we go. This one going this way, this one going up and down. The 2 fields perpendicular to each other. If at least respect the singularity of the photon, the individuality of the photon. Though I still think this is like not really. This is what we detect, maybe. This is like represents that slice, that sliver that actually fit in a resonant chamber. It was the electron orbit, right? This is the distance, the gap, in some kind of dimensional way, of the resonant chamber that this electron already had set up. This is just the wavelength that fit in that little pocket. But now you've got two of them, so now it will actually expand out and not be resonant to this frequency anymore, but be resonant to a different frequency because it just got a shot of a photon from outside. So either it's going to pop up or it's going to drop one someplace, give it away to somebody. Okay? But please respect the singularity of that. Though I still think, as I said in my photon video, I think a way better way of describing them is here would be electron shell. This is the S2. Drop to S1. This much movement. This creates a low pressure front here, and there's a high pressure front in there, so there's this like low pressure negative energy divergence, low pressure wave that propagates through space spherically, the entire waveform. So I don't know, how would I represent a photon actually? I would always represent it as a sphere with origin point there. Now, who knows, maybe it goes through a gravitational field so it gets wobbled and actually becomes some like strange, not truly spherical shape, but it would still be spherical if we measure the amount of Plancks from here to there. I'm going to say Plancks, that's energy or distance, because they're interrelated. Okay, so photons, I don't know, but it's got to be at least one, please. One single sine wave. One single photon, one single sine wave. Last one is the whole gravity thing. So ever since the Einstein relativity thing, planet, here, sun, whatever. Here we go. Curve space-time. But I notice in these graphs that it's like the curvature is only in this presentation dimension. And if you had rotated this whole plane 90 degrees so that you were seeing it from above, almost always this graph mesh is actually represented as remaining even. And the curve is somehow in this dimension that we don't understand. And I just think that's a really lousy way of representing it, honestly. Because gravity is a measure of the metric. It's the measure of energy in space. And that's the only way to measure space is by its energy density. Okay, mass is ridiculously high energy density space because it's a piece in orbit. So really it's more like, you know, the lines get pulled together here. It's difficult to draw, granted. But I guess this would come like this, and it would curve in a bit there. And this one would come like this, curve in a bit there. And this one would come like this, curve in a bit there. And this would come like this, but curve in a bit there. Okay, the actual metric is modified by gravity. Gravity densifies, like measure of the density of the metric itself. So it curves in all dimensions that way. But really, this shows that the field is moving this direction much better than this curve that you often use, which looks good. It's like, oh, you'd roll a ball down that curve. It's like, yes, but still, it's energy density. Everything's getting pulled. Everything is getting pulled. Energy is getting pulled this way. Matter's getting pulled this way. Everything's moving towards the middle. The density of the metric is different. Okay, it's not in a way we don't understand. It's holistic. Space is more dense in those places. So yeah, so 3 pet peeves of science. Or the way it's presented as an educator, talking to educators. It's like, why aren't we using diagrams that make sense? Okay, chronicle. Oh, actually, let's see. Let's hit one more. Promo. Whatever it is. Promo stuff. Weak force. I can't even remember because it's so ridiculous. Okay, A, the colors that you picked. You picked the light colors, so it ends up being white. Okay, I mean, the thing is, you have to make up weird names for anti-charges, like blue, anti-blue. It's like, no, the anti-blue is orange, okay? If you had picked colors that had, if you had picked the paint colors, you would have yellow here, and you'd go like, oh, well, purple is the anti-yellow. It's anti-charge. It's the opposite. Okay? Blue, orange, red, green. You'd already have your anti. You don't have to make up some weird term. You just have your anti-color built into it because you guys, the way the colors were picked, there's not proper charge opposites like that. Other thing is the 3 dimensions thing. 3 EM fields. 3 dimensions to space as we understand it. Okay? So there's 3 axes. This whole chromodynamics thing is like a complicated way of saying, if you want to be stable, you need 3 axes. If you want to be stable, you need 3 axes. Electron, 3 axes of charge. Negative. Positron, 3 axes of charge. Positive. Outflow. Electron, 3 dimensions. 3 axes of outflow. Positron, 3 of inflow. Okay? But why don't they have mass? Because they don't have one of those photons trapped in the middle. They're just charge. They're just inflows and outflows. But as I showed in my other particle physics thing, proton and neutron, the only lasting things. Okay? So that's our up. Now we'll add a down, which cancels this out. That in fact turns it into a photon. Negative cancels this out too, which turns it into a photon. And now we have 2 photons rotating over this. Apparently it doesn't matter how many you have. Once you have one, it's pretty much the same as the other. It's a little more dense somehow because it's like 2 photons. What I don't understand is when the conversion from proton to neutron makes sense. The construction of a neutron, though, okay, the charges negate, so now we just have mass. Spinning. And then, when it destabilizes, one of these remains in place. This one tangentializes essentially. right? Tangentializes, ejects one of the charges and keeps the other in place. It tangentializes, like expands, goes out of rotation and becomes the entire plane. Only this plane still has sort of outflow, inflow, or inflow, outflow resonance. Okay, I might have to cut that part out because this doesn't really have to do with the point of this video, which is my 3 main beefs with science presentation.